Welcome. In the life cycle of any long-running Linux infrastructure, specifically within the Debian and Ubuntu families, system administrators inevitably confront a specific friction point, the interactive adjudication mechanism of the package manager. Today, we are conducting a deep technical analysis of the conflict centered on the useradd configuration file. We will explore why this happens, the architectural shift known as useramerge driving it, and exactly how to resolve it without breaking your system.
This is the operational scenario. You initiate a routine system update, and the process halts. The system presents you with a diagnostic interface indicating a collision between local administrative intent and upstream distribution policy. It is not merely a question, it is a symptom of a divergence in system state. Specifically, the file on your disk differs from both the original installation and the new version the maintainer wants to install. This logical impasse requires a decision.
Our analysis follows three phases. First, we deconstruct the mechanism to understand how the package manager knows a file has changed, using cryptographic hashes. Second, we contextualize the conflict by examining the useradd initiative, which is the root cause of the specific anomaly regarding the useradd file. Finally, we will provide a definitive guide on resolution workflows, moving from manual intervention to automated fleet management.
To make an informed decision, you must understand the philosophy of Conffiles. In the Debian ecosystem, a distinction is made between files owned by the package, which are silently overwritten, and configuration files, which are meant to be modified by the administrator. The core rule is sovereignty. If you change a configuration file, the system should never silently overwrite that change, even if the maintainer believes their new version is superior. This prioritizes stability over newness.
When the prompt appears, three versions of the file effectively exist in the transaction space. First, the installed version, which is driving your current system behavior. Second, the new version extracted from the incoming package, waiting for your decision. And third, the original version, which is a checksum of the file as it was originally installed. The package manager performs a three-way comparison of these states. The prompt only appears when both the administrator and the maintainer have made changes relative to that original baseline.
A critical distinction must be made between useradd and adduser. The conflict we are analyzing affects useradd, a low-level compiled binary used by automation tools and system scripts. Many administrators exclusively use the friendly adduser Perl script and might think this conflict is irrelevant. That is a dangerous assumption. Because system processes call the low-level binary directly, misconfiguration here can break automated deployments and service account creation.
Let's look at the payload inside the file. It controls several key variables. Shell defines the default logging program, such as /bin/bash. Home determines where user directories are created. A critical security variable is inactive, which defines how many days after a password expires before the account is permanently disabled. In high-security environments, this is often tuned to strict values. A blind update can reset this to default, creating a silent security vulnerability.
Why is the maintainer shipping a new version now? The driver is the useramerge transition. In the 1970s, storage limitations forced Unix developers to split system binaries between the root partition and the /user partition. Today, that split is obsolete and complicates boot processes. Modern Linux distributions are unifying these directories. The maintainer is updating the configuration file to point to the new canonical path, shifting from /bin/bash to /user/bin/bash.
Understanding the context is half the battle. Now, we must evaluate the resolution strategies. When the prompt halts your production upgrade, what is the correct move?
Your mandatory first step is always option D, show differences. This generates a unified diff. In this example, we see two changes. First, the shell path is being updated to the new useramerge standard. This is good. However, we also see that our custom security policy for inactive is being reset to -1. This reveals the trap. Accepting the update blindly improves architecture but degrades security.
For complex conflicts, option Z is the gold standard. It drops you into a subshell where you can manually inspect the files. The workflow is precise. Open both the current file and the new maintainer file side by side.
Copy the updated shell path from the maintainer's version into your file, but preserve your custom security settings. Save the file, exit the shell, and then choose option N to keep your version, which you have just manually updated. This results in zero technical debt.
In automated environments where you cannot use a shell, you often rely on the keep old strategy, or option N. The advantage is safety. It preserves your local policies and prevents service disruption. The downside is drift. Your system retains legacy paths like /bin/bash. Over years, this accumulation of technical debt creates snowflake servers that behave differently from a clean installation.
For large-scale fleets, we cannot answer prompts interactively. The enterprise standard pattern involves passing specific options to the package manager. We use force_conf_def combined with force_conf_old. This logic dictates, if I haven't touched the file, update it. If I have touched it, keep my version. This prioritizes stability, ensuring that an upgrade never unexpectedly overwrites a custom configuration. If automation preserves the old file, how do we ever modernize? This is the role of configuration management tools like Ansible or Chef. After the package update runs safely, the CM tool runs to enforce the ideal state. The template used by Ansible should be updated to reflect the new UsrMerge paths while retaining local security variables. This makes the package manager's conflict irrelevant, as the CM tool acts as the single source of truth.
To conclude, the configuration conflict is not an error, but a notification of architectural drift. Your strategy should be rigorous. Always audit the differences. Use the manual shell merge for complex cases, where both security and architecture are at stake. And for the enterprise architect, update your configuration templates to proactively adopt the new standards, ensuring your fleet remains both secure and modern.